So today we are trying to study MCQs, okay? MCQs on what? Hydrocarbons part 2, okay? Very important MCQs. Literally very important MCQs. So now today 2,3 dibromobutane, okay? 2,3 dibromobutane when heated zinc when heated with zinc dust yields a number. There is ethene. B number. Sorry, there is something. Okay. Now second is 2-butene. C is 1-butene. And D is butane. Okay. So now let's solve it. 2,3 dibromobutane. So this is your CH3, CH, Br, CH, Br, CH3 when reacted with zinc, right? When reacted with zinc dust, this will react with this to bromine, right? So this will give you ZnBr2, right? And now there will be the formation of double bond, that is your this one. Okay, so this is your but2 in, right? So B number is the right answer. So next question. So what's the next question? Let us do this one. Which of the following is false? Okay, which of the following is false? So option number A is alkenes are more polar than alkanes. This is right? This is very right. Alkene is more polar than alkanes, right? B number, reactivity of alkene depends upon heat of hydrogenation. Reactivity of alkenes depends upon heat of hydrogenation. This is right. C number is alkene do not decolorize bromine water. Alkene do not decolorize bromine water. Actually this decolorize. This is the test of unsaturation, right? This is the test of unsaturation. So this alkene actually decolorize the bromine water, right? And also alkaline KMnO4 also, right? Alkenes are also called olefins, right? Alkenes are also called what? Olefins. This is right. So this one is only wrong. Alkene actually decolorize the bromine water, right? So now next question. This is which of the following compound has highest pp? Which of the following compound has highest boiling point. So option number A is here cis 2 butene. This is your cis 2 butene. Then there is trans 2 butene. C number, that is your propene, and D number is your ethene. So we have already read that boiling point is directly proportional to molecular weight. So among these, has four, butene has 4 carbon, this also has 4 carbon, this has 2 carbon, and this has 3 carbon. So out of this, these two are right are not valid, right, according to this. So either cis 2 butene has more boiling point or trans 2 butene has more boiling point, right? For the cis isomer, always remember cis isomer has higher BP than trans isomer. Trans isomer, due to its greater polarity. Due to its greater polarity, right? Polarity. Okay. Next question. 1 butene and 2 butene can be distinguished by, okay, so given here 1 butene and 2 butene can be distinguished by, their reaction with, so A number is alkaline solution of KMnO4, alkaline solution of what, KMnO4. B is your ammonical Cu2Cl2. C number ammonical AgNO3, and D number is non. Okay, first of all, let us discuss from here. This one is used for test of unsaturation. This one is used for test of unsaturation. Actually, whether it is 1 butane or 2 butane, it reacts with both, right? So this cannot be used. So now ammonical Cu2Cl2 reacts with alkyne only. Alkyne, that is also terminal alkyne to form acetylide, right? This is also same, right, to form acetylide. These do not react, these two do not react with what, alkenes. So option D is the correct. Okay, next question, that is your, which of the following compounds can decolorize alkaline KMnO4? Okay, which of the following compound can decolorize alkaline KMnO4? So the option A is C2H4, B is C3H8, C is CHCl3, or D is actually your CH4. So among these, this can decolorize because this is your alkene, right? Alkene and alkyne can decolorize this one, right? This is your alkenes, right? So this is test for actually unsaturation, right? Test for unsaturation. So unsaturated compound like this one, C2H4 can decolorize this one, right? Next question. Addition of Br2. Addition, addition, addition of Br2 to but2 gives a number 1,4,1,4 dibromobutane, B number 1,3 dibromobutane, C number that is your 2,3 dibromobutane, or D number that is your 1,1,2 dibromobutane, right? So first of all, you have to know the structure of but2, that is your CH3, CH double bond, CH3, this one, right? When you react this with bromine, this will give hydrolysis of a Br plus and Br minus. Okay, so look, this is symmetrical, right? It can attack at any position, here also, and this can attack here also, so it's symmetrical. So it's CH3, CH, Br, CH, Br, CH3. So symmetrical alkene, you don't have to think about the Markovnikov's rule or anything. So this is carbon number 2 and this is your carbon number 3, right? So this is your 2,3 dibromobutane. 2,3 dibromobutane. So now let's move. So now next question, and the next question is sulfur monochloride. Okay, sulfur monochloride reacts with dash to give mustard gas, mustard gas. Okay, so option number A is ethane, B is ethene, C is ethine, and D is methane. Okay, so you must know this is actually the reaction of alkene, right? That is your C2S4, actually CH2 double bond CH2. So it is here ethene. It reacts with S2Cl2, that is a sulfur monochloride, to form what? That is your sulfur, and there will be Cl, S2, S2, CH2, CH2, S2, Cl, and sulfur, and this is your mustard gas. Right? Mustard is your mustard gas. Okay, so the next question is, Markovnikov's rule is applicable for, so you know, unsymmetrical hydrocarbons. In unsymmetrical hydrocarbons, Markovnikov's rule is applied, right? So next question. So here given for a reaction CH3 CH double bond CH2 plus HOCl, which gives A. The product is. For these such type of questions, right, you don't have to worry. This is electron donating group, right? So this will gain negative charge and this is gaining partially positive charge, right? And this gives OH minus and Cl plus. So you have to attack in a OH minus and Cl plus. So you have to attack in a similar manner. Attack this over here and attack this over here, and your product is ready. And that is your CS3 CH OH CH2 Cl. That's what your product is. Okay. Next question. What is formed? What is formed when calcium carbide is reacted with heavy water. Option number A is C2D2, is B is CaD2. Option number C is Ca2D2. Number D is CD2. So let us come here. Okay, so now what happened when we react calcium carbide with water? So what is this gonna give? That is your CH triple bond CH. That is your C2H2, right? What if the same reaction is carried with the help of heavy water? That is your D2O. So this will be giving you, that is your CD triple bond CD, and this is C2D2. That's what it is asking. Okay. So now next question is electrolysis of cold conch. Electrolysis of cold conch potassium malate yields. So this is actually Kolb's electrolysis, right? Kolb's electrolysis. So here it is given carbon dioxide. B is given carbon dioxide plus water, C2H2 or D none. Alright. So you must understand this Kolb's electrolysis, that is your C double bond CH. This is COOK. This is your potassium malate, right? So this is your potassium malate, right? When you do electrolysis of this one, so this will give COO minus, and this is your COO minus plus 2K plus, right? This is at anode and cathode, right? Furthermore, this will lose 2 electrons to form this one that is CH triple bond CH plus 2CO2. This will gain 2 electrons, right? It will gain 2 electrons over here, and this will react with water to form 2KOH plus H2, right? This is what happening, right? So actually this is your C2H2, right? So this is the answer. That is your acetylene or ethine will be the product. So the next question now over here is, okay, sodium acetylide, okay, on reaction with C5Br gives C2S5Br gives. So this is actually RC triple bond C Na, right? Are you getting it? Na plus and C minus actually. So this is what your sodium acetylide is. When you react this with C2S5Br, this Na will take this Br, right? And this will give you RC triple bond C C2S5 actually. This is happening, okay. Or actually you can write this as like this, RC triple bond C CH2 CH3 in this manner, okay. So the option is actually the same like sodium acetylide, right? Sodium acetylide means this R group is actually sodium acetylide. This is what your reaction is. So after you take here CH, okay, sorry, this is H, right? Acetylene means two carbon only, na? So this is H, R is replaced by H. So put here H, HC triple bond C CH2 CH3. So this is 1 2 4. So this is but 1 ine will be the product, right? But 1 ine will be the product. So the option is actually butene to butine 1, C is butine 2, D is all of these, right? So this will be the answer. So next question, let us go with the next question. When you have to remember this, when CH3 CH2 CHCl is reacted with NaNH2, this will produce alkyne, that is your CH3 C triple bond CH, okay, C triple bond CH after removal of these two chlorine from here, that is your propine, okay. Next question, the reaction of, okay, ethane can be oxidized to, so given here ethane can be oxidized to what? Oxalic acid by, so first is alkyne MnO4 KMnO4, strong oxidizing agent, chromic acid or C number HOCl or D number all, okay. So it is especially by the alkaline KMnO4, okay. Alkaline KMnO4. So the next question that we are going to do over here is acetylene can be converted to, okay, given here acetylene Phthalene can be converted to methyl vinyl ether. Methyl vinyl ether by given here, that is your okay, A number vinyl alcohol, okay, B number is methyl alcohol, C number is dimethyl ether, D number is non. Okay, so actually what is the chemical formula of methyl vinyl ether? Vinyl ether. So this is actually CH2 double bond C O CH3 and there is H, right? This is what. So let us react this with CH3 OH, right? So this is your minus and this one will be plus, right? Over here H plus. So react this. This is your HC. Anyone, you can put anyone like OCH3 double bond CH2. So this is what your methyl vinyl ether is. So this is methyl alcohol. Okay, up to here we have done. So in next we'll do further more questions.